And it's very easy to build a skeleton. I get this thing here. This it's like really easy to build a human skeleton. Anyone can do that. And this is, kind of faithful to what it's doing. It's got a few things here that aren't exactly the way the human body works, but it's close enough. Now, the trick is, how do you put the motors in there to make this do that? Okay. That's where it gets a little bit harder, is figuring out what they're going to be. And there's many, many different approaches, and they're all they're trying to find what is the best approach. And some of them are trying to put, 3 different motors in the shoulders, because our shoulder can actually rotate in 3 different directions, and trying to figure out how to put them together. And they'll be using what they call rotary actuators, so that, if you want to rotate about the shoulder this way, you get a motor that just goes back like that. And then you get a different one that will make sure you can do this. And you've got to put them together in such a way that you can run the cables through without the cables getting all twisted up, make sure it's not too heavy, and also have kind of a faithful movement to it. Well, others are thinking, oh, wait a minute, that's not exactly how our shoulders are built. It's like we don't have 3 different motors in there. We've got a ball and socket joint. Yet, if you look out there, all the robots that are out there, the humanoid bots, they don't have a ball and socket joint. Now, a ball and socket joint is almost as easy as a hinge joint. So your elbow is a hinge joint. And if you don't know what a hinge joint is, just look around your house. All right? It's like your door has got a hinge on it. And sometimes it's called like a pin joint or something like that. So basically you get these 2 mechanisms to come together, and you put a cylindrical pin through it, and it just allows everything to rotate about it. That's a fairly easy thing to do. But the funny thing is, even though we represent our elbow as a hinge joint, the human elbow is not actually a hinge joint. It's like these 2 things that kind of rub together, that are held together by all these tendons and muscles that you can approximate pretty well with a hinge joint. But when it comes up to the shoulder, our shoulders are actually a ball and socket joint. And you get examples of ball and socket joints around your house if you've got like a camera tripod. I mean, that's a perfect example. It's a really easy mechanism to build. It's a really hard mechanism to actuate, to get it to move. It's like, yeah, you can get your hands and grab it and move around where you are and tie it down. But if you're actually trying to actuate it, gets to be a bit challenging. So a lot of them give up on that. And they decide, oh, we'll just use rotary actuators. But there are others that are saying, hey, let's see. And it's Actuator, which is another company. They're doing everything with what they call linear actuators. Okay. So rather than having a motor that kind of spins, you have a motor that when you turn it on, just makes things kind of go in and out. So they extend. And, kind of an analog, if you look at like the screen door in a house, and I know it's going to vary around the world. I'm just thinking like an American house, others a little bit different, but you have a screen door and it's got this damper on it that helps the mechanism close. And it's like a piston cylinder there. Okay. That thing's there to slow down the movement of the closing of the door. But imagine, rather than slowing it down, if you actually put a motor in there that would extend that would push it out, it would cause the door hinge to open out and to close back in there. And that's the kind of mechanisms they're thinking. And Tesla's actually got a mechanism like that in the elbow. And some of the other robot companies do, and some of them don't. Some did a direct rotary actuator there. And others are thinking like, well, how do we put these little linear actuators on the shoulder to make it move? And that would be one way possibly of doing it. Now, if we go back to science fiction and you look at C-3PO, you will see C-3PO has what looks like these little piston cylinders coming out on his elbow and up here, because, Lucas and others were trying to imagine, okay, how would a mechanical man work like that? How would the actuation done? Because we know when you open up C-3PO is like tons and tons of wires in there and stuff like that, just because the Hollywood producers said, that'll look cool. Just tons of wires in there. We don't know what they do, but it looks great. But they were thinking, everyone's going to wonder how it moves. And you'll see also in his head, like these little things that are on there that kind of like, are going to stick up and move. And so you're already imagining that. And they're not far off of that would be a potential way of actuating some of these things.